There's going to be a bunch of right-hand rule questions on your test, mostly multiple choice, but also it makes a nice part B to a written question asking you to give me a direction. And again, especially for the tricky one, the right-hand motor rule, where there's three things, if I give you any two of the directions, you can backtrack and figure it out. Name, well, it's good old Anne, right? I'm sensing some students are still wrestling with this. I'm going to go very slowly, especially because some of you were away. So the following diagram, it says, shows a charged particle or a current carrying wire in an external magnetic field. That means it's going to be the hi-fi hitchhiker right-hand rule version, or you can use the three-finger one that I just can't do. For the diagram, use the right-hand rule to draw an arrow on the object that shows the direction of the magnetic force. Okay. Why is number one a trick question? They're parallel, no force. So number one, no force at all. Number two, now I'll need to do this. I'll do this as though that's my piece of paper. So I have a charge going, a positive charge moving upwards. I have a magnetic field pointing to the right. What direction is the magnetic, what direction is the force? Which direction is my palm pointing? And so I would show into the page by going like that. And I'll just put an F to label it, but if you didn't, that's okay. Number three, current moving to the right. Magnetic field is straight up. Ooh, what direction is the force going to be here? How do I show out of the page? Or if I'm typing, it'll just be the dot without the circle because it's a pain to put the circle around the period. It says a negative charge into the paper. Do I deal with negative charges? No, no. A negative charge into the paper, Raj, is the same as a positive charge which way? So I'm going to point my right thumb out of the paper. Magnetic field is that way. Which way will this feel? Okay. By the way, if you're wanting to follow with my screen and you want your paper to be oriented, just hold your piece of paper up like this, and that way you'll match exactly what I'm doing. Hold your paper vertical, and we will be doing the same thing. That might be, if you're struggling with this, a good move to do. Which way was it? Yeah. Oh, we got someone late. Pause the video for a second. Number four. B is out of paper. You know what? I won't say out of paper on the test. I'll expect you to clue in. Now, I didn't put the circles around it because it's a pain. Periods out of the paper, X's into the page. Is this a positive charge? Yes, it is. Positive charge is moving to the, oh, again, don't bend your fingers like this for this rule. You want to be flat, hi-fi, hitchhike. So that way, out of the paper, is it down the page? It's down the page, I think, yes? Shko, I don't know what you're doing. That was totally wrong. There's no way your palm can be pointing upwards. Okay? Thumb this way, magnetic field pointing out of the page, palms pointing downwards. Yes? Ooh, diagonally. Okay. Current up and right, magnetic field into the page. You know what? Force is going to be that way. Boom, boom, boom. Yes? Current is out of the page. Magnetic field. Oh, I got to bend my hand. Oh, like this. Pointing to the right. My palm is pointing which way, Shko? And in terms of that's my piece of paper, the force is going to be up the page. Ooh. An electron traveling up and left. Do I deal with electrons, Ella? Up and left, same as a proton traveling down and right. So I'm going to point my thumb this way. What direction is the magnetic field, Ella? Okay, you know what? I think it's going to get forced that way. Yes? You can do the three. I just can't bend my hand like that, Raj. If you look on YouTube, there's also a way to do it with three fingers, but I do the hi-fi hitchhike method. Okay. Oh, Turn the page. So that page, I guess, was out of 8. Determine the orientation of the magnetic field for each of the following 3 coils. So 1 mark each. Let's see. Current is going, Kira, this way, this way, this way. Yes? So I imagine holding the solenoid. I can hold it like this, or I can hold it like this. Would not be right because my fingers need to curl in the direction of the current. I'm going to hold it with my fingers curling over the top with my thumb pointing to the right. So what does that mean? This is the North Pole. This is the South Pole. The magnetic field outside would look like this. The magnetic field inside would look like that. Anyways, it just said label which end is north and which end is south. So 1 mark, all or nothing. B. Ooh. You know what? I'm not even going to do. Yeah, you're right, but it's the opposite of A. So I'm pretty sure north, south. Yes? C was a trickier one. I really had to think about this. Okay, hang on. Current going this way. Oh, no, wait a minute. This isn't too bad. Curling over the top. You know what? North there, south there. Okay. 3 marks, 1 mark each. Ooh, this third one is going to be a little tricky. This first one, determine the direction of the force on the wire so the magnetic field would point this way. What direction is the wire in that picture carrying the current? That's, oh, that dot in the wire means out of the page. So current coming out of the page, magnetic field line points from north to south. You know what? I think F is going to be up the page. By the way, these will almost certainly be multiple choicey questions on your test. So it would be to the left, to the right, up the page, down the page, into the page, out of the page, right? Ooh, now the wire is going current Mesa into the page. Yes, so thumb into the page. Magnetic field points to the right. Mesa, which way will that middle wire feel a force? This third one, I said, oh, I'm going to have to figure out what direction the magnetic field is from the solenoid first. And then I'll figure out how that wire is going to feel a force. So I said, okay, zoom in, Mr. Dueck. Label the current. Current. Okay. I can hold the solenoid like this or like this. You know what? I think I have to hold it like this. I think the bottom of the solenoid is the North Pole. The top of the solenoid is the South Pole. Magnetic field lines always point from what to what. So I'll really exaggerate it, but this magnetic field, now I got to shrink it down a little bit, would go from north to south. I think right there, the magnetic field would be pointing downwards towards south. So what direction is the current in the wire? Out of the page. What direction is the magnetic field right there? Downwards. So I'm going to point my, no, Dan, out of the page. Thumb out of the page, right? Fingers downwards. You know what? This wire is going to feel a force to the right. Sketch the path of the charged particle. Assume the particle is a proton. Proton moving to the right, magnetic field out of the page. It's going to be a circle in that direction, half circle in that direction. Magnetic field into the page. It's going to be a half circle curving in this direction. Yes? If you don't do a like if your circle doesn't look perfectly circular, I'm not going to be fussy as long as you have it in the first one curving upwards in a way and the second one curving downwards. 1 mark each. Can you give yourself a lovely score out of 16, please? If you need to lawyer with me, now is the time.